Hello, good morning. We're going to start our second session. Thank you for being here. My name is Guillaume Pitron. I am a French journalist and I am moderating this second panel. Earlier this year, as you might be aware, don't hesitate to ask your questions on Slido for the Q&A session by connecting on the QR code. Earlier this year, as you already, I guess, are aware of, the International Energy Agency published a very interesting study and saying basically for fighting adequately climate change, the world will have to produce by 2040 40 times more lithium, 25 times more graphite, 7 times more rare earths than in 2020. And the executive director of the IEA, Fatih Birol, added that the data shows a looming mismatch between the world's strengthened climate ambitions and the availability of critical minerals that are essential to realizing those ambitions. Potential supply shortages may lead, I shall even say are already leading, to competitive usages of CRMs in new growing sectors. And in 2020, it's been already said in the precedent panel, the DG GROW precisely mapped such risks in this study entitled Critical Raw Materials for Strategic Technologies and Sectors in the EU. And we can see here by looking at this graphic that some looming competitive usages arising between wind energies and electric mobility for rare earths. And also we see 3D printing and ICT may compete in the future for access to magnesium, germanium or scandium. All these risks, are these risks well considered by new growing sectors, highly reliant on CRMs? What strategies are being deployed to mitigate them? I would like to address these questions with our two experts who have developed different approaches for addressing these risks in two specific sectors, that is health and IT. Dr. Luis Tercero Espinoza, good morning. You are the coordinator of the business unit raw materials at the Fraunhofer Institute in Germany. Good morning. And Thea Kleinmag, you are a circular material chains innovator at the Dutch company Fairphone, a social enterprises company that which aims to develop smartphones which are designed and produced in a more environmental way. Thea, Fairphone, is developing a circular economy chain to lower the environmental impacts of the 90,000 Fairphones that you produce each year. But circular economy can also aid mitigating supply risks. I'd like to hear you on that. Please, you have the floor.
Yes, thank you very much, Guillaume, for the introduction and also for this invitation to take a little bit of a different perspective than Fairphone usually does on the materials that we use. So you can see here how it all started, because we need a little bit of an introduction to the company that you understand the background here. So it started all in 2013 as a campaign for conflict minerals and the risks related to that. But the company noticed very quickly, or we were not a company back then, but that you have to become actually a part of the system to be able to change the system. And also there were many consumers that wanted an alternative to the normal phones that were on the market, a more sustainable alternative, but it was just not present. And in 2013, that led then to the launch of Fairphone 1. And now we are actually already at Fairphone 2 that we recently launched. So Fairphone's mission is that we raise awareness on the issues that are there in the electronic supply chain, and then we prove that it can be done differently. So we are piloting new approaches and then motivate the industry to follow us in that. Our normal focus areas here, you can see the fair materials, longevity and take-back have a lot to do with critical raw materials, although we don't call it usually like this. What we do is that we first need to know what is actually contained in our phones. So you can see here a very, let's say, simple simple illustration on what the supply chain of electronics or a smartphone looks like. So now already in the second tier, where you see 6 icons here, we have more than 50 suppliers that supply us with the components, which then maybe 2 or 3 tiers down actually integrate the materials, among others critical raw materials. You can also see that we conduct a scoping study, seeing how important those materials are for smartphones, but also what the supply situation looks like. But we also look into social and environmental impacts, and with that decide on what materials we want to focus on. So basically we have our own list of critical raw materials for us in these 3 perspectives, but we call them focus materials. Here you can see that Fairphone follows a modular approach, so it is easily repairable and also easily disassemblable when you think of circularity. And all these different modules, they contain different materials, which is of course important when you think of the recovery of those materials. When you know where they are, you can target them way better to keep them in the loop. Keeping materials in the loop. Most of the industry is usually talking about recycling when it comes to closing the loop. But as you can see here, we conducted a recycling study, and it turned out that when you recycle a Fairphone, you can only recover 30% of the materials in the best case. And that's of course also a limited amount of different materials which you can recover. So you can mostly not recover the critical raw materials that are contained in there. And this is why we at Fairphone, we really focus on trying to reuse modules and phone for as long as possible before, as the last solution, recycling is considered as an option. And here, as a summary, what we do to achieve that is the outer loop. Probably you have heard about the term narrowing the loop and not just closing the loop. Recycling is the last option with 30% of recovery, thus 70% of material losses. But we reuse complete phones. We also collect modules to then reuse them to repair phones that have been sent to us. And with that, of course, we can then basically recover 100% of the materials and prolong their lifespan. And with every phone which can be repaired and every module that can be reused, we prevent that another phone or another module needs to be produced. So we save on the production of new components, but at the same time we also prevent that we directly go to recycling and with that lose a lot of different materials in the phones. And here, well, you can see here basically a summary of what we achieved now during the last year. Thank you very much, and I will now hand over to Luis.
Thank you. Well, basically I understand that the best circular strategy is to keep phones as long as possible. Luis Tercero, I understand that the Fraunhofer Institute already conducted an assessment of the raw materials needs in the health sector, which is a sector which consumes lots of raw materials and critical raw materials. Could you share the results of such a study with us?
Yes, it would be my pleasure. Good morning, everyone. It's great to be here again in person, really. Can we, if we could get this the screen working again, that'd be great. In the meantime, use that one. Yeah, I'm going to speak about 2 or 3 studies that colleagues of mine did on the health sector. And when we're jumping from, a product like a mobile phone into the health sector, we have 2 big jumps to make. First, we are not going for one particular product, we're going for a whole sector. And second, the sector is providing a service and it's using raw materials for that service. And that's why we usually don't see the health sector in studies as a featured area of interest. Nevertheless, there are a lot of raw materials that are necessary to provide those services. So this first study I'm going to speak about is about Germany and raw materials demand in Germany. And in 2016, that was 110 million tons of raw materials that were required to provide this service in Germany. And these raw materials came mostly from chemical products. So this is what's behind all of those plastic single-use things that we have. But we also have a lot of food and beverages for there, and we have construction and energy as very large sectors. And then the things that you would expect to find in a forum like this one would be the medical devices, where we start to get more intricate devices to provide those services. The need for raw materials has been increasing in the sector. So if you look at the overall raw material use in Germany, it has been stagnating. So there is a decoupling between GDP and raw materials use. In the health sector, this has not happened. It's actually on the other way around. The raw materials need have increased a lot. Most of that, a lot of it comes from biomass, fossil fuel, energy, and non-metallic minerals. But there is a small and important part that is actually metals. So that's the view from the sector. That's a top-down view at the whole. In a separate study, we jumped into individual technologies. So this is a study that was made for the German Raw Materials Agency, and the idea here was very different. It was not looking at entire sectors, but individual technologies that represent a sector on the one hand, and on the other hand, we have an expectation that they will require significant amounts of raw materials in the future. So in this particular study, we had something on the order of 250 candidate technologies, and then they went through an initial screening of their market potential and the raw material requirements. And then there came out a selection of technologies. And in 2016, the next to last version of this study, we had two medical technologies in it. One of them was medical diagnostics, looking at CT and MRI, and the other one was medical implants. There are all kinds of interesting issues that come up with this. So when we start talking about recycling, for example, recycling of a medical implant that we carry in our body, basically until we die, if everything goes well, raises up a number of interesting issues. And then we have also different logic to the use of this very large pieces of equipment, where it's not distributed across a very large number of consumers, but there are many, but still limited, number of users of that equipment, such as in hospitals or specialized clinics. So we looked at tomography, and most of that, and CT, computer tomography, and MRI, most of that uses, say, mass produced, so industrial metals, iron, copper. There are some silver, there's gadolinium in there. The use of helium in MRI was out of scope back in 2016. Looking at the new list of critical raw materials, we would have maybe chosen differently, but the scope was made such that gases were outside. And for the implants, we looked at cobalt, chromium, molybdenum, and titanium. And overall, there's a need for these metals. They are key. You cannot provide these services without them, but the tonnages are not very large. And that's the reason why in the new screening, in the latest report, these technologies weren't featured anymore. So we have on the one hand side, when you look at the overall need for raw materials in the health sector, it's very large. When you zoom into the critical raw materials, they are providing a critical service, but their tonnages are not very large. Nevertheless, you cannot do without them. So, thanks.
Thank you very much. Then you share a common point. Whether it is the health sector or Fairphone, the health sector and Fairphone have very strong needs for raw materials and critical raw materials, but in terms of volumes, so volumes are very low. And my question is, this specificity, can it be seen as a chance for avoiding supply risks due to competitive usages with other sectors and companies? Is it a chance to have small volumes needed for your businesses? Or on the contrary, maybe it's harder because you don't have the priority for getting them?
Yes. So for us specifically, Fairphone is a very small company. So every year about 1.4 billion of smartphones are sold. With our, well, close to 100K of phones that we sell, we don't even come close to 0.1% of the whole phone market. So for us, the volumes of materials that we purchase is really small, and we also don't directly purchase the materials, but we purchase components where there are also a lot of suppliers involved down the supply chain, which actually purchase the materials in those components. But for us, it is, you could see it as an advantage that we only need small volumes, and we also really actively engage with our supply chain, so we have good partnerships to, to purchase those materials. But on the other hand, of course, since we purchase small volumes, we are also a very small customer for other companies. So if Apple purchases components and materials, then of course they have a way higher purchasing power than we do. And that means that they are probably in the advantage, and only partnerships, and that it is more and more seen as an asset to have Fairphone as a customer that can help us to get to the components that we need.
What about you, Luis Tercero? Your sector, the health sector, uses few, as you said, critical raw materials and raw materials in general, but still, I mean, can you escape such a risk of overlaps with other industries? Do you have the possibility to pay premiums, for example, to get better access?
There is no way to escape those overlaps. If you look at across the board of for critical raw materials, they tend to be used in several sectors. And if you look at the machinery that we've been seeing, you see a lot of electronics in there. So there's an imminent overlap with electronics. There you have overlap also with the general mechanical engineering sector and so on. So the overlap is there. What the medical devices sector has on its favor is that it's a lot of high value equipment and it's not very high volume. So there's an advantage to needing a smaller amount of raw materials, and there's a lot of know-how in the devices, so that the raw material costs tend to be not as significant.
Okay. When we prepared this interview, this panel, Luis Tercero, you said it's a tough business to get specific figures about needs in the sectors we study, what kind of needs they have in specific raw materials. And you especially said it's hard to get figures from the industry. So I turn to you, Ter Kleinmag. How do you share your figures? Do you share your figures with the public sector, or is it such an industrial secret that actually communication doesn't go through? On the other hand, do you have any interest in public space research reports being actually done on a specific IT sector by the Fraunhofer Institute, for example? So the question is, how do you both can bridge the gaps in terms of communication in order to make your understanding of the needs for CRMs and raw materials stronger?
Yeah, so in general, Fairphone is always interested in sharing information and also partnering up with other experts on digging deeper into the issues that we have in an electronic supply chain. And that accounts for also the environmental perspective, the social perspective, and then of course also the critical raw materials that are related to both of these perspectives. Because what's often seen from this risk approach of critical raw materials, there are also social factors considered, but mostly rather as a risk than as an opportunity that you can actually improve something. But yeah, what we see is, of course, with the different materials that we need in our sector. They are, for the batteries, for example, they are also needed for the energy transition. And yeah, building mining capacity needs a long time, and we see that this will be mostly replaced by small-scale mining, these materials, but that comes often with large environmental and social issues. And there we would definitely be very interested in partnering up with other parties to have a closer look at this. And also concerning the Fraunhofer Institute, we are also very interested also in studies on smartphones that they conducted, for example, also now for the review of the Eco-Design Directive. So there also the Fraunhofer Institute has worked out a very in-depth study on smartphones and the market around smartphones and the environmental impact. Yeah, so definitely yes.
Luis Tercero, you feel the business secrecy, the difficulty to actually get access to the information and to conduct better global assessments?
Sometimes it is, and there are legitimate interests behind it, and I think it's a matter of really finding out where there is a reasonable amount of information that can be disclosed without disclosing anything that would be worthy of protection for the companies on the one hand. On the other hand, there was a point that Thea mentioned, they're not buying the raw materials directly. So oftentimes they don't know what's in there. So we come around and we may tell company X, you know, you use, say, tantalum in your products. Could you tell us more about it? You know, how much is it? How do you deal with new scrap and so on? And they may just not know that it's tantalum because they have a manufactured product in their hand where they can't see it. And if you look at things like environmental product declaration or LCA studies, bills of material, then you go down and you find things like steel, you find things like aluminum, brass, zinc. But you will not find some of the smaller so-called technology metals that really make a difference for the product, but they're not as important in the tonnages or in the mass of the product at the end. So they may just not know. And the interest to know there is something that has to be created through discussion and communication.
Sure. What about the 5G devices technology? This is certainly a technology which is a common point between the health sector and the IT sector. This technology will spread and certainly being used by both sectors. To what extent will this new technology potentially impact future criticalities, both in the health sector and the ICT sector? Do you have any vision about where new criticalities could arise? Or is it maybe too difficult to figure out?
Yeah, from our perspective, of course, 5G bears the risk of that a lot of smartphones will be replaced when consumers see the need for getting a faster device. And this is, of course, for us always a challenge because all those materials that are in the phones out there, they then will either go to recycling, best case, or for reuse, but a lot of them will end up in the drawers, and that's where it's very hard to get them out again and keep the materials in the loop. At the same time, of course, the infrastructure which is needed for 5Gs, there are way more antennas needed, more locally placed, and of course that's also a high demand for raw materials. And for us, definitely, it is something to consider. But that we also encourage still, because of course the other networks are still in use, so that also not 5G capable phones that are kept for as long as possible, so that the materials also stay in the loop.
I would have to peek into our latest report on raw materials to not say anything wrong, but there is a chapter about 5G and 6G technologies in that report, Raw Materials for Emerging Technologies, that just came out the middle of this year. So I'd invite you to look at that. You have to practice a bit of German, but the figures are readable anyway, and there is an English version coming up soon on it. The thing about 5G is it's a cross-sectoral technology, right? So it's not just going to show up in our smartphones. It's going to be used in the Internet of Things and in different uses, and especially there where this low latency of the connection makes really a lot of sense. So in having a latency of something of a second or less, it's probably enough for a patient communication to the nurses, but it's definitely not enough for controlling machinery across kilometers of distance and downstairs. So I think, it's my personal feeling, I'm no expert in the area, but my feeling is that we'll see a lot of production facilities and things that really need to be closely tagged that will be using a lot of that technology away from or in addition to the devices that we have.
Thank you. Just to a thing I have in mind, Thea, when we prepared this interview, eventually you said, well, the best way to tackle a supply chain risk strategy risk is actually to sell less phones. How scandalous that is. Anyway, I just want to go back to the questions that are being asked by the audience. We have many questions on Slido. I want to ask the first one, which is to you, Thea. This is a question, is Fairphone using or requesting any traceability system for the raw materials used in the different components to secure their sustainable origins? Would you like me to repeat?
Yes, please.
Because it's a bit hidden here on the screen. Is Fairphone using or requesting any traceability system for the raw materials used in the different components to secure their sustainable origin? What about the blockchain? You said you don't use a blockchain.
Yeah, no, we don't use blockchain at this point. We are always often approached by partners to collaborate there, but we are a small company and it also takes a lot of resources to really look into that point. But it really depends on the material. So we have these 14 focus materials, and there we try to secure more sustainable supply, so fairer materials, which can either be responsibly mined materials or recycled materials that we integrate into the phone. And depending on those phones, on those materials, we have different strategies. So that can either be that we, for example, use a mass balance system, so that every supplier mass balances the fair material that goes into the supply chain, so that we can really we really know that it is connected to our supply chain, but usually our volumes are so small that we cannot, for example, keep it separately from the other materials that are used at this supplier, because we, for example, only then need half a bar of gold, and of course this is a unit which doesn't exist in industry, so we have to work with such methods to be able to connect the materials to our supply chain and make it traceable where it comes from.
Luis, the last question is for you. Is there in Germany any law or recommendation for orthopedic pieces to be donated to recycling or reuse, similar to organ donations? Tough questions, but...
Yes, tough one. I haven't looked at this in the past few years. The thing about an implant is it's a part of your body, so you cannot, it's not something you can inherit while it's a part of you, and then the people who survive you, your family, they have to take care of it but not recycle it. So it's a really, really thorny issue that falls in the cracks, and to be frank, not many people like to talk about what's going to happen to the thing. It's very easy, I guess, and it depends on there's a big difference between burial and cremation, right? So it's a really, really tough question, and the last I looked, it's just not solved yet.
Okay. Thea, for you, the two next questions that come together, what do you think about the policy of many high-end manufacturers to make it almost impossible to repair their phones, even with original parts? And then should the EU aim for policies that help the right to repair?
A clear yes, please. So we are all in for policies that help the right to repair, because from our perspective, this is really the key to save resources, because as I explained in the beginning, recycling is not the solution. So we need to start higher up in the hierarchy with repair and keep all the products that we have in use for as long as possible, so that we can really make use of 100% of those materials. So this is really super important. Also, that manufacturers get some rules that they have to comply with, to not have the system in place for longer, in which selling more phones is the way to make money, because that encourages, of course, such practices that you cannot repair a phone, but that you have to buy a new one, and this is against everything what we want.
Mm-hmm. Many people in the audience ask for your data, Thea Kleinmag. Would you be open to share this data with the research team currently working on governance and global value chains of rare earths? And will you share what are the focused materials of the Fairphone? Is rare earth one of them? Do you want to answer any of those two questions which come together? Actually, they could come together, and would you like to share them?
We are always open to share data, so this is how we support and how we also help to drive the change in the industry. So please approach me. You can find me on LinkedIn and we can discuss it.
You can't discuss.
Sorry?
You can or you can't? I didn't get it.
We would like to share data, yes.
Okay. Is there any question in the audience that you would like to directly ask, or we have still 3 minutes to go? You precisely mentioned, Luis Tercero's question of gallium, which the potential criticality of gallium has been pointed out sufficiently early in order to make sure that there wouldn't be any criticality arising in the future. Is there any other example you'd like to give us of critical materials that whose criticality was avoided precisely by this strategy of understanding these issues right in time? Mm-hmm. And I have the same question with you, Thea Kleinmag. I remember when we discussed this panel, you mentioned the question of gold, which is a metal which is present in the Fairphones, and you were very much aware and worried a couple of years ago about this potential criticality of gold, and eventually you figured out that it wasn't such a critical metal. But yeah, I'd like to hear more about how can you organize sufficiently in advance your strategy and your knowledge of potential criticalities in order to answer to them.
So gold is such a case where it is a precious metal, so it is relatively well recycled, but at the same time the demand is higher than what we can recycle, so we always need mining for be able to provide the supply that we need. And this is why we at Fairphone go there in responsible mining, because we also know that gold is connected to a lot of issues in the supply chain, because much of the gold produced is produced by small-scale and artisanal miners, meaning that they basically produce the gold with their bare hands and use chemicals which are very hazardous. They are bad for their health, but also polluting the soil. For example, mercury emissions. It's the largest share of global mercury emissions comes from the small-scale mining sector, and this is why we focus here on mining and not on recycling, because the market for recycling is already there. But we need this fair transition to a circular economy, and we need this fair material which enters the circular economy.
Luis, do you want to add something?
Going back to the issue of looking ahead to future demand and whether it will be too much for supply or not. It's of course, the second you make such a scenario, you know it's wrong, right? So the idea is to show the consequences. So you're asking a question about how much would we need if we made the products that we think we want to make in the way that we today think we are going to make them, and in the quantities that we think we're going to make them. So what we found out in 2009 on that original study was that there was a lot of need, a looming very large need for gallium, and the way to compare that to supply was to say, well, how much of what multiple is it of the supply that's current? And it was several times the entire supply of gallium at the time. And what happened was that on the one hand side, the supply increased, because it was possible to increase gallium supply out of the aluminum production. And on the other hand, there were some serious gains in efficiency for the products using, and there was some technological change. So 5 years later, gallium was not the problem that we thought it was going to be. And of course, I'd like to take credit and say, well, the companies looked at a report and did everything to change it, but I think a lot of that is just normal, the normal way the market works. But looking ahead of that is a valuable part of it, because it allows you to react to the consequences of the course that we are taking at a particular time.
The technological landscape is changing so fast. Have you ever experienced a situation where suddenly a metal would appear on your critical radar as being so important, so critical, but you hadn't actually seen that metal becoming critical in the short term? Have you ever experienced such a situation where a technological upheaval would actually completely change? Would actually make new risks and new critical activities appear that you hadn't expected?
I can't think of a good example of that right now. There are scares that come up because material development and the development of new technologies, it takes a long time. So a lot of things that you see at the level of, say, scientific papers, things coming out of a university lab, you can start thinking, what would happen if this technology were there? And then you get the idea, well, there would be a lot. And then they don't take up in the market because something new comes up, or because there's a better solution, or whatnot. We were talking a lot about scandium for aluminum alloys in aerospace some years ago. If you go and look at what's being used right now, it's a lot of lithium aluminum alloys. They came up and they have taken hold much more quicker, and lithium is cheaper than scandium is. So scandium is still there. There are things that are still being made of it, but it didn't take on this huge market volume that we were expecting. It does happen. You find a new material, you find a new technology, and then you start playing with the consequences of that. And along that road, almost anything can happen. Yeah.
Would you actually react, Thea Kleinmack?
Yeah, I would say for us, since we purchase components, we don't purchase the materials, and we also currently don't look too much into, let's say, the supply chain of the materials, because, not the supply chain, but really the supply issues of the materials, because often those are like 5 steps down our supply chain. So it's rather our 3rd or 4th tier suppliers that actually purchase the material. So for us, it's mostly that, we get to know that we can at this moment not purchase this component, and only if we really ask step by step, it can be that this is related to a shortage in the raw material supply chain. And so we right now don't really have the possibility to really see and monitor if a specific material will cause problems in the future for our components that we source.
Thank you very much. It's 12:30, so I don't want to keep you longer. We have things to go after that. Thank you very much, Chris Tesseros. Thank you very much, Thea Kleinmack, for your insights. Thanks.
Thank you.
Pleasure.